Hi, pre-calculus students. Welcome to section 5.5, double and half angles. This is the section that is last on your memorization sheet, and I have listed number 6 and 7 on your memorization sheet here for us to use so we can all look at that. If you remember from our no trig warm-up, that cosine of 30 degrees does not equal sine of 60 degrees divided by 2. And so that is not true for double angles or for half angles. So let's point that out. When you have 2 times an angle, we call that a double angle. And when you just have the angle alone, like u, 2 sine u, cosine of u, we call those single angles. So notice for sine of a double angle, we have one formula for in terms of a single angle. For cosine of a double angle, we have 3 possibilities of formulas for formulas with single angles in them. And we have one for tangent of a double angle. And then these are our formulas for half angle formulas, right? Notice that sine and cosine have a plus or minus in front. It does not mean that when you have your final answer, you have a plus or minus in front. It means that you have to choose one or the other based on your location. So why do we have double angle and half angle formulas in terms of single angles? Because most of our information is given to us in terms of a single theta or a single u. And so when they ask us questions about a double angle or half angle, now we can use that single angle information. So the examples we're going to do, is a number 4 here. So we will have A through F. And so how do you solve these problems? Just like in 5.4, we are going to determine which identity to use, what pattern do we have. Next, we're going to use our given information and find missing information. And then we're just going to do our math. Sometimes the algebra is the hardest part. So looking down here, let's do example 4a. If we are asked to solve cosine of a double angle plus sine of a single angle equals 0. So we're trying to find the x's that make this equation true. It is okay to have a double angle and a single angle in the same equation if you can separate them and set them each equal to a value you know on the unit circle. Notice that's not true though. With cosine here, with cosine of a double angle and sine of a single angle on the same side of the equation, right, they are dependent on each other. If I were to subtract sine of x from both sides, they're still dependent on each other. So this means to me that I have to replace cosine of a double angle with a single angle identity. I have 3 to choose from, 1, 2, and 3. Any of these 3 would be just fine. But I think based on the fact that I have sine of x in my equation, that I would want to pick the middle identity so that I only have sines in my equation. So I am going to replace cosine of a double angle with 1 minus 2 sine squared x. So I just replaced cosine of 2x with this expression plus sine of x equals 0. Okay, well, this looks quadratic to me. Not real happy with the negative on the front. So if it's okay with you, I'm going to go through and multiply every term by a -1 because it's legal. And I'm going to put them in quadratic order. So I'll have a positive 2 sine squared x minus sine of x and a -1 equals 0. Okay, if you don't like the signs being in here, when you factor it, you can go ahead and make them x's to do your quadratic factoring and then put the signs back in. But I am going to go ahead and do that. The first terms have to multiply to 2 sine squared. The only possibility is 2 sine of x and sine of x, right? Notice when we multiply, We have 2 sine squared. Notice last I have to have a -1. And so that's either a -1, it has to be a -1 times a +1. So there's only 2 possibilities for placement. I'm going to put my -1 here and my +1 here and see if when I multiply this out, if I get the expression above. That would be 2 sine squared minus 2 sine of x plus sine of x is a minus sine of x minus 1. So I think we're good there. Now I'm going to set each factor equal to 0. And if it's okay with you, I'm going to do a little numeric work also, right? So 2 sine of x plus 1 equals 0. I'm going to subtract a 1 and divide by 2, right? So right here, I am 1 step away from having my answers to x. And then sine of x minus 1 equals 0 would be sine of x equals 1. Okay, 1 step away from having my solutions. Let's take a look here. So sine is 1/2, better work that out on my hand, at pi over 6, right? We can do radians or degrees. Let's do degrees. So that would be at 30 degrees. Sine would be 1/2. And sine is negative in the 3rd and 4th quadrant. There we go. So x equals 210 degrees, 330 degrees, plus 2 pi n. And then where is sine equal to 1? That happens at 90 degrees. Plus 360 n, right? So my 2 pi n, of course, is supposed to be in degrees. I switched to radians by mistake. So our total answer for our angles, there we go. Okay, gonna hit pause and get a new problem up. All right, problem B, another proof. We're gonna prove that sine plus cosine squared is equal to 2 sine of a double angle plus 1. I drew my squiggly line. I cannot cross over these 2 sides here. Please understand that sine of x plus cosine of x, when you square it, is not sine squared plus cosine squared, which is 1. That is not true. What we're going to do is, what is sine plus cosine squared? Well, let's write it out. It's sine plus cosine times sine plus cosine. There we go. All right, let's go ahead and FOIL that out. I would have a sine squared from my first term. On the outside, I would have plus cosine x sine of x. On the inside, I have another cosine x sine of x, so that's 2 of them, and then plus cosine squared. There. That's what you get when you FOIL that out. Now, take a look here. My 2 sides will never be equal if I have single angle here and a double angle here. And so I have to do something. But what I'm going to do is keep going on the left, because here's what I see. I see that sine squared plus cosine squared is 1. And I have 1 plus 2 cosine of x sine of x. Okay. Now, I want this side to be the same, and I see that I've made a little error. So if you would, but I don't want to restart the video, right? So see this, I thought I rewrote the equation wrong. Come on down here. When you saw that B, it's supposed to be sine of a double angle plus 1. Sorry, there we go. And erase that too. I miswrote it. But I've gotten so far into the video, I don't want to fix it. So if you're okay with that. Okay. Now let's take a look. Notice that 2 cosine of x sine of x looks familiar to me. And when I come on up here, I see, look at that, it's sine of 2u, right? It's sine of a double angle. So I am going to replace, I'm going to keep my 1, and then I'm going to have 2 sine of x cosine x is sine of a double angle. And notice these are both equal to each other. So again, I hope you don't mind that I erased the 2 in the front here and here. I just had too many 2's, and I didn't write an identity that was equal on both sides. So go back and make sure that you start from this point here. And now both sides are equal. Thank you. Hi, I'm back. Let's try C. If you have been given this picture, you are being asked to find cosine of a double angle, sine of a double angle, and cotangent of a double angle. Okay, based on single angle information. Well, let's first get this hypotenuse. The hypotenuse would be the square root of 17, right? And let's see, we want cosine of a double angle. Now, I can use any of these formulas that I wish. How about if we use the last one this time? So that would be cosine squared of theta minus sine squared of theta. Any one of these 3 that you pick will get you the same answer. Okay, so cosine of the double angle is cosine of theta, right? I'm going to get that from my picture. That's 4 over the square root of 17 squared minus sine from my picture is 1 over the square root of 17 squared. Notice I don't have to worry about the square roots of 17 in the denominator because they're being squared. So we get 16 17ths minus 1 17 equals 15 17ths. And that is the value of cosine if you doubled that angle. Sine of 2 theta, just come on down here, is equal to this formula that you see here, 2 sine of theta times cosine of theta. Well, we already had sine of theta. It was 1 over the square root of 17. Cosine of theta was 4 over the square root of 17. Notice we didn't have to worry again about the square roots because when we multiply, they will eliminate. And we have in the numerator 8 17ths. Let's do tangent of a double angle. That is equal to, we could just simply do the formula over here, right? Or couldn't we do sine of a double angle divided by cosine of a double angle? Right, we already used them. So let's go ahead and do that. Sine of the double angle divided by cosine of the double angle. And we'll multiply by the reciprocal instead and get 8/15 is tangent of that angle doubled. Okay, let's take a look at problem D. You have been given this picture in the right triangle, and they are asking you for what would be cosine of that half of this single angle here. Well, let's first get the adjacent side. Let's see, that would be when we do the Pythagorean theorem, this would be a side of 12. Okay, and let's look at the formula for cosine of a half angle. Here it is right here. It is plus or minus the square root of 1 plus cosine of theta divided by 2. Okay, now notice because we do not have any quadrants, that this triangle is located in the first quadrant, meaning that all of its values are positive. So we are going to choose the positive answer. Let's go ahead and fill in cosine of theta from our picture. That would be adjacent over hypotenuse, which is 12/13. divided by 2. Now, this is a perfectly correct answer, but I think we can make it look a little bit better, right? Let's make this one 13 thirteenths plus 12 thirteenths divided by 2 over 1. And we have 25 thirteenths in the numerator. And rather than divide by 2, let's multiply by the reciprocal. And we have the square root now of 25/26. The square root of 25 is 5. The square root of 26 is not perfect. So there's a correct answer, but they probably rationalized the denominator. So we will too. And our final answer is 5 square roots of 26 over 26. So for this angle here with the given information, if I took half that angle, its cosine would be 5 square roots of 26 over 26. Okay, let's take a look at problem E, right? So all these problems that we're doing, you have been given different information and you have to find different missing information. So sine of a double angle, given that secant of the angle is -2, and of course, we're going to call that -2 over 1 because we know these trig functions are all fractions with the numerator and denominator, where u is located in between pi over 2 and pi. So notice they're asking us for sine of a double angle, and that is cosine of sine of u and cosine of u. So notice to use this formula, I need sine of u and cosine of u. Let's draw ourselves a picture. If u is located between pi over 2 and pi, right, then you must be in the second quadrant. Here's my u. Now, if secant of u is a -2 over 1, then cosine of u must be a -1/2, right? And so I can put that right here. And I can put it in my picture. A -1/2. All right, all I need is sine of u here, and I will be able to use my formula. So let's see, this side would be using a Pythagorean theorem, the square root of 3. Notice it's positive. Also, I have to check to see if it's positive or negative. And so sine of u in this picture is, here's my 2, and sine of u is the square root of 3 over 2. And sine of a double angle, of this double angle, then these 2's cancel, would be a negative square root of 3 over 2. So notice I always fill in the information I have and look for my missing information. Let's do the last problem. All right, our last problem. On F, they're asking us to find tangent of 67 degrees 30 minutes using a half angle. Now, what they're asking us for, because you're probably like, well, I can just throw this in my calculator in degree mode. They're asking for the value exactly using information from the unit circle. Okay, so let's write the tangent of a half angle formula. Let's see, tangent of a half angle. Oh, we can do 1 minus cosine of u over 2. Look, I think I wrote this too quick. I'm gonna come and look at the. I wrote my board late at night, and so I think that I wrote some things wrong, and so I'm going to check. Where's my memorization? So tangent. I'm looking at our memorization sheet, right? Tangent of a half angle. Yep. Gotta change this. There we go. That's not a 2, that's a sine. There we go. I had too many 2's going on. Okay, so we can, tangent of a half angle is either one of these formulas. We can use either one that we want. Let's use the first one. That would be 1 minus cosine of u over sine of u. Okay, so how do we do this? We need u, right? If we had u, we would be doing well. So here's what they're saying. They're saying tangent of u over 2 equals tangent of 67 degrees, 30 minutes. Okay, now let's make tangent of 67 degrees and 30 minutes a decimal, okay? Just because it's easier to use. When you put that into your calculator using degrees and minutes and ask for a decimal, obviously 30 minutes is half of 60 minutes, and so you get 67.5. So degrees. So notice what's happening here. To be able to find u, my u over 2 has to equal 67.5 degrees, right? So this means tangent of u over 2 means I have to multiply this angle by 2 and divide it by 2. So it equals 67.5. I know that sounds confusing, but I'll show you what I mean. I'm going to multiply 67.5 times 2. That is 135 degrees. There, and divided by 2. So let's take a look. See how I match this up. Tangent of a half angle, they told us to use it, has to equal tangent of 67.5 to answer this question, right? So tangent of u over 2 then, notice I doubled 67.5 because 135 divided by 2 is 67.5. But now I can see my u, right? Some u is some angle divided by 2. In my case, it's 135 divided by 2. Okay, let's put the 135 here, in here. Okay, this is perfectly correct. Let's do the math though. I did bring my unit circle just because I should know what cosine of 135 is on my own, but there's so much math going on, I didn't want to mess it up. So cosine of 135 degrees is a negative square root of 2 over 2. And now it's positive. And sine of 135 degrees is the square root of 2 over 2. Okay, now this is perfectly correct, but this is not how the answer is going to look in the book. So what they're going to do is they're going to take the numerator and multiply it by the reciprocal rather than dividing by this fraction. Right, so this problem is the same. So let's go ahead and do that. When I multiply 1 by 2 over the square root of 2, I have this value plus, notice when I multiply the square root of 2 over 2 by its reciprocal, I get a 1. So this is perfectly acceptable answer. And you may find that it looks different in the book. They may actually, rationalize the denominator here, right? So they'll have a 2 and 2 square roots of 2 plus 1. And then the 2's cancel. There we go. So even though we were perfectly correct right here, they probably rationalized the denominator on the first fraction, right? And then had their plus 1. There we go. So you have the square root of 2 plus 1. All right, class, sorry for the extra work, but I just felt since I had miswrote B, I just wanted to do it again written correctly. Okay, so this is a true identity. We just need to physically show that it is. As stated when I tried it earlier and miswrote it, that sine of x plus cosine of x squared is not equal to sine squared plus cosine squared, which is equal to 1. It means we need to FOIL out the binomial. And when we do that, we get sine times sine is sine squared. On the outside, we have a sine times cosine. On the inside, we have the same, so we have two of them. And last, we have plus cosine squared. Okay, now what I see on the left-hand side is that sine squared plus cosine squared is 1. And I have 1 plus 2 sine of x cosine of x. And then I go, you know what? This looks familiar, doesn't it? 2 sine of x cosine of x. Isn't that one of my formulas? It sure is. It is the formula for sine of a double angle. And now both sides are equal. You also could have kept this expression and then looked over here and said, hey, that's 2 sine of x cosine of x plus 1. You could have changed this side and proved that they were both equal. There, I feel better now that I did it right. Have a great day.